So in the last video, we talked about breaking down a topic or a course goal into its steps or components so we could write our topic level learning objective. But there's more to understanding something than just a list of steps.
I start by thinking of my course as delving into a terrain of topics. And I think about what aspects of that terrain do I really want students to know deeply? What do they need to know on a superficial level? And then I start to kind of map out how they're going to go from one place in the terrain to the next and how the ideas build on each other. So my learning goals often are kind of the big ideas of that terrain and then also the connections between them.
So let's start mapping this terrain. What kind of ideas can your objectives focus on? Think on your own for a moment about a topic that you've taught and what kinds of things that a student needs to do to show you that they have mastered that topic. So I'll give you my idea of mapping. One of the first things I want to think about is what types of learning I want my students to have. So one type is just cognitive abilities, facts and concepts. Do they know the terminology and the details? Can they classify and reason about the concepts? So that's the more traditional part of learning that we think about. But there are also these procedures and skills that go along with that, the techniques and methods and problem solving that we want students to master, what it means to think like a physicist or think like a mathematician. There's also metacognitive aspects of learning, so a self-awareness about what it means to learn a topic or what helps them learn, so helping students really master some studying and learning strategies. And lastly, there are the attitudes and beliefs that go along with science, really not necessarily liking science, although that would be a goal, but really a deep appreciation for the value that science brings to the world, or mathematics or engineering. So not seeing it as something that doesn't relate to life or isn't useful. So these are all aspects of practicing science, and they're really just as important as thinking about the topics that you're teaching. So let's look at some example objectives and look at what type of knowledge is being described in that objective. So here's one. Tell me what type of knowledge you think is being sampled in this objective. So this, I would say, is an example of a cognitive skill. So we want students to be able to understand something about the physical and chemical properties in the periodic table. What about this objective? So this one falls really in the attitudes and beliefs. So answer D, recognizing that physics is something that is valuable for understanding the world. Here's another objective. Which category do you think this one falls into? So this is a really great example of a metacognitive goal. So it's giving students an idea of what it means to learn about probability. Here's one last example. Which category does this one fall into? So this is an example of a procedural or skill-based goal. You want students to use data to determine the cause of an environmental problem. That's a part of thinking like a geologist or thinking like a scientist. But now there's another way we can analyze learning objectives, not just the type of knowledge, but there's something else. Let's look back at these three goals from the Three Little Pigs. What do you notice about these goals? Which one of these choices best reflects what you think about these goals? So for me, I'd say that all of the above are true. These are very clear how you would assess these goals. There's a variety of different verbs, so we're really getting at different kinds of skills. And then some are simple and others are more complex. So let's look at that part. These goals are really getting at ideas from basic recall to more challenging tasks. And we really do want our students to achieve different levels of understanding. So here's Jenny Knight to talk about a tool that can help us think about these different levels of cognitive difficulty. It's called Bloom's Taxonomy.
This is called Bloom's Taxonomy. It was developed in 1956 by Benjamin Bloom, and it's been revised multiple times since then. It's handy because it's quite straightforward and maybe even simplistic. There are other tools that are more complex, but faculty generally like to use Bloom's Taxonomy because it is fairly straightforward. So we think of Bloom's Taxonomy usually as a triangle, and so what we do with that is we put the lower order skills on the bottom and the higher order skills on the top. So at the very bottom of the pyramid is remembering. And remembering is exactly what it sounds like. It's something that you would be able to memorize. So for example, list the steps of photosynthesis, to give a biological example. That would be a remembering type of skill. Doesn't require too much thought, but it does require that you memorize something. The next skill level up is understanding. And understanding has to do more with being able to describe or explain how something works. So it's a little bit harder. You could still have memorized a definition to something, and in describing how something works, you could really be just using that definition. But it is considered one level up because you should be able to discuss or explain your idea a little bit more fully. The next level is apply. And right above apply is analyze. So applying and analyzing are I would say, very close to each other in terms of their cognitive order. To apply something, one has to think of how to use something in a new situation. One also might need to integrate some of the prior skills like remembering and understanding. So, for example, drawing a diagram would be applying your knowledge in terms of relating how those various different things might apply to each other. So for example, drawing a diagram of photosynthesis, that would be something that would be more at the application level. In addition to applying, there's analyzing, and analyzing is often looking at data or a figure or a table or making a prediction about something that would happen in the future. Interpreting often is a good verb to think about for the analysis level. I often think of analysis as a really good way of getting the students to use skills. So anytime you're asking them to use some skills in terms of taking a scenario and comparing it, contrasting it with another scenario, or deciding whether there's enough information there to actually fulfill whatever the question is being asked, all that would fall under analysis. And then at the top of the pyramid is evaluating, and then at the very top, creating or synthesis. At the very top of the pyramid, you're trying to get students to make judgment calls. That would be the evaluation component. So evaluate whether this experiment demonstrates the following principles, and that could be in any discipline. Or at the synthesis level, actually putting things together into a big picture. So for example, we notice that students sometimes have trouble understanding the role of carbon. I mentioned photosynthesis earlier. So you might remember that plants use carbon, but you might not realize that animals exhale carbon dioxide. And so in asking a student to create a big map and follow how a carbon atom goes from the atmosphere into a plant and then into an animal and then back out into the atmosphere or through a decomposer or something like that would be an example of having somebody synthesize the whole system of photosynthesis and respiration and how those two things correlate with each other. That would be at the very top order of the pyramid. What you'll notice right away when you're thinking about the different Bloom's levels is that they build on each other. And so if you're at the top of the pyramid, you're using skills that you had already mastered at the bottom of the pyramid.